This is the solution to problem 73 on homework 1.3. And we're told that a grocer mixes peanuts that cost $2.49 per pound and walnuts that cost $3.89 per pound to make 100 pounds of a mixture that costs $3.19 per pound. How much of each kind of nut is put into the mixture? Oh, I have a typo here. Mixture. Let's fix that. Okay, so this is a weighted average problem, but I find that it's helpful to create a table when facing these problems that'll help us set it up and solve the problem. So we have to figure out what is it that we're mixing. In this case, we're mixing walnuts and peanuts. So I'll write peanuts first. So that's what they tell us about. First, we're mixing peanuts and walnuts, and together they create the mixture. So that'll be our third row. The first row is going to be our heading. Then we need to figure out what's important about these items that we're mixing. One thing that we can see is we're told the price per pound. So I'm going to write down dollars per pound. And the other thing that we know is how much. So this will be the pounds. And if we multiply across, this last column is always the product. In this case, it'll be dollars per pound times pounds, which will be dollars spent on that item. That's what our product is going to turn out to be in this case, given the units that we have. Okay, now we're going to fill in what we know. So we know that for peanuts, they cost $2.49 per pound. So I'm going to put that in the corresponding cell. And walnuts cost $3.89 per pound. And the mixture is supposed to cost $3.19. So I'll put that down in the mixture cell. And then how many pounds of each? Well, we're told that we need 100 pounds of the mixture. And rather than using two variables here, what I would recommend is we'll define our variable. That's always something we need to do when we're doing application problems. So I'm going to say let x equal the number of pounds of, I'll say peanuts here. You could use either one, the number of pounds of peanuts. And if x is the number of pounds of peanuts, I'm going to fill that in our table. Then I can figure out the number of walnuts without using a new variable, because the number of pounds of peanuts plus the number of pounds of walnuts has to equal 100. So the number of pounds of walnuts has to be 100 minus x. So like if we have 20 pounds of peanuts, we'd have 100 minus 20 or 80 pounds of walnuts. Then we're going to go ahead and we're going to multiply across each of the rows. So we'll have 2.49x. We'll have 3.89 times 100 minus x, and we'll have 3.19 times 100. And now we can say whatever we're going to add, peanuts plus walnuts is going to give us the mixture. So in this case, it's the dollar spent on each, which will be equivalent. So we can say 2.49x plus 3.89 times 100 minus x, that's the walnuts, has to equal the mixture, 3.19 times 100. And now we have our linear equation that's set up. So we have 2.49x. I'll distribute the 3.89 to the 100 and minus x. So plus 389 minus 3.89x is equal to 319. And then we'll combine like terms. So 2.49 minus 3.89 is minus 1.4x. I'll subtract 389 from both sides. So that'll give us negative 70 on the right side. And then we'll divide both sides by negative 1.4. And x turns out to be 50 pounds. And I'm going to answer in a complete sentence. So that would be, we need to use, how much we need to put into the mixture of each. So use 50 pounds of peanuts and 50 pounds of walnuts to create the desired mixture.